Yeah, so the size size gives you the total number of elements in that array, right? Size gives you the what? The total number of elements in that array, right? For instance, we have got 3 sets of 4 rows and 5 columns, which means 4 multiplied by 5 will give us what? Which means in each set we have got 20 elements. Then 20 elements multiplied by 3, since we have 3 sets, will give us what? Will give us 60, right? So just as you can see here, each array has attributes: n dim, the number of dimensions; shape, the size of each dimension, right? Then size, the total size of the array, right? We may want to change here to 2, 2, right? And here 2, 2, 2. I want you to see the difference, right? So we all know x2 is a 2-dimensional array. This one, x2 is a 2-dimensional array, right? And the size is 3, 4. Then the total number of elements in the array is 12, because Smogot is 3 multiplied by 4 to get what? To get 12, right? So another useful attribute is the d type. We talked about the d type in previous sessions. It is the data type of the array, right? So if you type x3 dot data type, you will discover that it's int 32, right? It's int 32, and int 32 here it's like the default. It's the default data type, because we didn't explicitly set the data type for the elements of this array, right? Other attributes include item size, which lists the size in bytes of each element. So the size of each element, until we've got all these elements, so the size of each element within that array, we get that size through this function item size, through the function item size, right? And n bytes, we also have n bytes, which lists the total size in bytes of the array. So the difference between n bytes and item size is that n bytes, it looks at the whole array and gives you the total number of bytes of the whole array. But if you want to look at individual elements within the array, you have to use item size. So this is how you do it, item size. So we know that you see that in this array, which is x3, which we are working on, each and every item in this array is of size what? 4 bytes. And since we have 60 elements in this array, the total size of the array in bytes is 4 multiplied by 60, which will give us what? 420, which we can get through invoking the n bytes function, which is this one, right? So in general, we expect the n bytes, that n bytes is equal to item size. This is what I was doing. 4 multiplied by the size, which is the number of elements, which will give us 60. 60 multiplied by 4, we get 240. So now we want to look at array indexing, which is very tricky. So I want you not array indexing is not tricky. Slicing is the most tricky part. So we are going to move a little bit slow so that you guys understand. So if you are familiar with Python's standard list indexing in Numpy will feel quite familiar to you and easy. In a 1-dimensional array, you can access the ith value counting from 0 by specifying the desired index in square brackets. So you have to count from 0. When you are indexing, you don't count from 1, you count from 0. The first element in an array is always indexed at 0. Confusion. For example, this is what we have, right? This is what we have. And now, if we want to discover the element which is positioned at is an index 0, this is how you do. You use square brackets and write the index number that you want to look for. So as you can see here, at index 0 we have 5. At index 2, right? At index 2 we have 3. We have 3. Right? At index 4 we have 7. 0, 1, 2, 3, 4. So to index from from the end of the array, you can use negative indexes. So we are saying to index from the end, this is the end of the array, you use what? Negative indexes, whereby -1 is the last element, -2 is the second from last element, like this. So that x, if you index -1, you get 9. If you index -2, you get what? 7, because you're moving from the end of the array, from the right side of the array, moving towards the left side of the array. This is very important, guys. You have to understand this one. So in a multi-dimensional array, you can access items using comma-separated tuples of indices. You may be wondering, how then can I index elements in a multi-dimensional array like this one? This is a 3 by 4 array. Right, so this is the array that we have here, and now we want to index 3. If we want to index 3, we start with the row and the column. So we are saying the value that is positioned at row 0, because ma 0 anofamba achiti 0, ma rows anofamba achiti 0, 1, 2, ma columns anofamba achiti 0, 1, 2, 3, right? According to the indexing, you know it by. So if you say 0, we're saying what number is it at row 0 and column 0? That number is 3. So what number is at row 2 and column 0? Let's look at where is row 2. 0, 1, 2. And column 0, which means 1 is at column 0 and row 2. This is how you do it. Which value is at row 2? 0, 1, 2. And the last column, minus means the last one. And the last column is this one. So which number is in the last column? It is in the second row. The number is 7. This is how you do it. I'm going to give you some exercises for you guys to do, so that you familiarize yourself with how you index multi-dimensional arrays. So you can also modify values using any of the above index notations, right? If you want to modify a value in x2, we want to change the value that is positioned at row 0 and column 0. So originally 3 is the value that is positioned at row 0, column 0, and we want to change this number to become 12. This is how you do it. You assign 12 to this indexed value, such that your array is not 3. Instead of having 3 here, which was here 3 was replaced by 12. So you have to keep in mind that unlike Python lists, Numpy arrays have a fixed type. What does it mean with a Numpy arrays have a fixed type? This means that, for example, if you attempt to insert a floating point value to an integer array, the value will be silently truncated. So you shouldn't be caught unaware of this behavior. So what does it mean the value will be silently truncated? It means Python will not report that there is an error that has happened. It will not report. It will truncate, which means it will give you the floor of that value. For example, we have 3.14, and the floor of 3.14 is what? You remember the concept of floors and ceiling. So floors, it means we go back. So we are going back to the next smallest integer after 3.14, which is 3, which means we're going to simply ignore everything that comes after the comma and put an integer, which is 3, right? So this is how the truncating works. So x1, 0, at index 0, you remember our one-dimensional array. So the number that was positioned at 0 was 5, if you remember. So it's now going to be replaced by what? By 3. So let's see what will happen if we try to put 89999. What is going to happen? It is still going to use the floor. So you should remember that it will give you the, if you are using a float value, you know, to get masure to this next smallest integer, which is 3. So we are done with indexing. I want you guys to practice indexing a lot. Practice. Now we want to look at slicing, array slicing, right? Just as we can use square brackets to access individual array elements, we can also use them to access sub-arrays. with the slice notation. It's like we are creating sub arrays from the main arrays that we have. From a cake, you are taking a slice. You are not taking the whole cake, but you are just taking a what? You are just taking a slice, marked by the semicolon character, which is this one, right? The NumPy slicing syntax follows that of the standard Python list. It's the same. And to access a slice of an array X, you use this. This is what you use, and this is the format that you use. The first number is the starting number, separated by a full colon. The next number is the stop number, and the last number is the step number. This is very important. If any of these are unspecified, if any of these are unspecified, they default to the values 0. Not kanapana first number, personal number, it is specified. It means you're going to put a 0. You're going to start at 0. Then stop will be the size of the dimension by default. Can also explicitly set the number. Then step, if you do not explicitly set the step number, it will default to 1. We'll take a look at accessing sub-arrays in one JDN. I'm in a lecture. In one, sorry for that, I have to stop this class.